So, this is another one of my crazy ideas, which is probably not so crazy. 10 years ago, crazy and expensive, but today, maybe crazy, but much cheaper. So, who has pets? Alright. Now, what if you lose one of them? Or somebody steals it? How will you get it back? I don't know. So I was thinking about that, about my dog. Where is she? Baba? Baba? Yeah. Here she is, my dog. Yeah, Angelina. She's not accustomed to sitting on the table. Anyway, this is my fluffy child. And if she was to go missing or somebody was to steal her one day, then I wouldn't be very happy. Okay? Okay, you're just gonna lie down. Shake. Good girl. So, I was talking to my wife and I says, what if someone eats her? What if someone takes her away? You can't find her, right? You'd be lost. So I proposed an idea. I thought, because I'm already working on my university thesis, which involves a few things, but one of them is a microcontroller. Now, the other day, ESP8266 Node MCU, I think, for those of you that are interested. Anyway, I powered that for the better part of 3 days while maintaining a constant connection to a database, transmitting every 5 seconds, I like to say. So the process was like this. It's on. It will connect to a database, transmit, then disconnect, then wait 5 seconds, then connect, transmit, disconnect, wait, connect, transmit, disconnect, wait, every 5 seconds. And it did that for 3 days before the battery dipped too low to power the circuit. Now, I was being very lazy while powering this. I was using an, it's fine, I was using an lithium ion battery, 18650 cell, you know, the ones that measure 18650. And I started with full charge, 4.2, and it the controller couldn't work past 2.8 volts or something like that. That's when it turned off. Now, the controller, I think, can function at 3.3 to 5 volts. Obviously, if you run it at 3 volts, the CPU power won't be as much, but what's to say you don't need that much power? Anyway, so I did this with all without any kind of voltage regulation. So it started off with 4.2 volts, and I just let it drop. So if I did have a simple circuit to just output 3.3 volts, I reckon I could have gotten another 2 days with that same kind of transmission rate. And what's I gonna say? And that's with the battery circuit will have a low voltage disconnect at about 2.4 volts, so it'll keep functioning. I also have a cat. So it'll keep functioning until it hits 2.4 volts, in which the circuit will turn off the battery because it's not healthy for the battery to discharge that low. Anyway, so that's it. I can get 5 days of microcontroller transmitting data every 5 seconds. Now 5 seconds is a bit on the high frequency side, and I ran into problems with my database server. It was like, hey, this is when I learned about max connections on the database server. I was like, hey, the server's crashed or something. What's going on? and then I check the logs, and it's like, hey, these quadrillion connections to the server, some didn't close, or some just stayed open, and so couldn't access the database server anymore. So I changed the max connections to some crazy high number. But then I also solved the problem. I was like, okay, properly disconnect, please. And you don't have to transmit every 5 seconds. You can do it every minute, or for my solar power tracking system, every hour or half an hour. So anyway, so I gave you 5 days at 3.3 volts, transmitting every 5 seconds. I can't do math off the top of my head, but let's say every 10 minutes, transmit to the database server some information. And then, anyway, you get more than 5 days. So, battery power problem solved there. Now, back onto track. So, let's see. Okay. So I started to write some things down. So this is my dog or animal collar, tracking collar, So what it does, transmits location data gathered from a GPS module over 4G. So we have 2 things using power now, 2 more things using power. 4G antenna and GPS antenna. Okay, so microcontroller, GPS, and the 4G antenna. So 3 things so far. The 18650 cell is a little bulky for an animal to wear around its neck. A lipo cell, like the ones you find in your cell phone, could work. Would be a better fit because come in many shapes and sizes. So maybe a lipo cell. Charge by USB-C, easy. You don't have to try 3 times to plug in your USB plug. It fits, and it'll last the longest. USB-C is fine. Now, I started adding more things onto it. Like dogs, they have a collar, but they also have a tag, and the tag gives some license information. And where I am now, I think license information doesn't really mean anything. If your dog's gone, it's gone. So one thing I looked into, you buy the ebook readers, and those batteries last for years because the display is only refreshed when you need to turn the page. So it's only using power when you need to turn the page. So that's e-ink. And so I thought, e-ink, okay, I can have an e-ink collar, e-ink tag. And then I searched, and I was like, yeah, e-ink is a little expensive. And then I saw one more, e-paper. Now this can be rolled up and screwed up. Not recommended, but it's durable and cheap, really, really cheap. So an e-paper tag here. And on the e-paper tag, you can have whatever you want, program from the microcontroller, scrolling text, a little picture, or my name is blah blah blah, I'm from this house, please return me. So a programmable tag. Psst. Programmable tag. Now I thought, okay, while I'm on adding I2C devices, why not add some more? How about add a microphone to it? So adding a microphone, I would also need to add microphone and storage, and then I will also need to transmit that data over the internet. More power, that's fine. And then next, Bluetooth programming. So for the initial use, like after my microcontroller is programmed, you program it via Bluetooth, connected to Bluetooth. And you say, hey, I want the e-paper to say this, and maybe this is my server information, transmit the GPS data here. Now, GPS data will show on a map. The map I'll probably borrow from someone that offers a map service like Google. Maybe I can do that, and it'll just plot information there. X, Y, maybe Z. If I can do Z, I don't think so. Yeah. So then the shopping list consists of a GPS module, has to be programmable, SIM module, 4G. Why I mentioned it's cheap now because I can get a SIM card and it will cost just a few dollars a month, and the data, you will never use that much data anyway. Microcontroller for controlling everything pretty much, battery for powering it, a collar to work from, just a normal collar, insulation for waterproofing, and something for battery safety. Charge controller for the charging circuit, for the, how I say plug in the USB-C charging controlling circuit, the buck boost circuit. So, depending on the battery's state of charge, whether it'll buck or boost is entirely up to the circuit. Optional, so I said sound. Do I need a sound card? An I2C sound card? Maybe I do. So with that, I also need storage because you record with a microphone and maybe you'll need to transmit every 10 minutes or something. So you need to store to the mic, store to the card, and then send to a server. And so because of the limitations of the microcontroller, you will not be able to really store anything compressed. So it'll be uncompressed big.wav or something like that. Bluetooth module for programming features, and the e-paper display to show important information. Why the microphone? In case someone steals your dog and they're talking about it, they're like, haha, I got this dog. Yeah, this is my house. I'm at this house now. And so you just have some more information. You have, because everybody here lives in big buildings, so you're not just gonna go up to a building and be like, okay, my dog's in this house, when there's like 10 houses a floor, 30 floors, so 300 houses. So having a microphone will give some more information. Yeah, and the total cost, I think I can, the biggest cost is time, obviously, but I think I can get it to less than $20, $20 US easily. GPS module, 4G module, those are cheap. The microcontroller, really cheap. The most expensive part, most expensive single part might be the battery, or even the storage, the MMC card or SD card, or the e-paper display. So yeah, everything else I can design, the boost converter, I can tie everything together. I've made some pretty pictures on how it's going to work. Okay. Yeah. So over here, e-paper display. Yep. What did I do? I just drew a whole bunch of picture. Where's the microcontroller? So some can connect to the microcontroller. What did I use yellow for? I think blue was connected to the microcontroller. Yellow was for power. Yeah, yellow is for power lines. Forgive the crudity of this model as I did not have time to draw it to scale. Get that reference. Okay. So the blue must be the data for the I2C lines. The yellow is the power. So power comes from the battery into the buck boost converter. And then I'm hoping everything can run on 3.3 volts. So I don't need to do anything else. So everything can just 3.3 volts, everything. Microphone power might be interesting. Bluetooth, fine. Alright, so data connections to the microcontroller. So I got GPS, got the SIM, got the storage, got the microphone, and e-paper, which should be connected in blue. Where's my blue line, bro? And power. And power, so power, all the same. GPS, SIM, microcontroller, storage, Bluetooth, paper, and yeah, here's me hoping I get 3.3 volts. I think I drew another picture. I tried to make it pretty. So this is what it's gonna look like. The initial prototype will probably be something bulky like this. But when I decide to make it into a single PCB, I think it could be just this big, or even maybe aside from the battery, it could all just sit on the back of the e-paper. So GPS and Bluetooth, keeping all the communication in one spot. And a PCB design, I guess, is not really that great. You have some interference. Maybe it doesn't really matter. Storage, microcontroller, battery buck boost, charge over here. But yeah. After creating it, then I can draw a schematic, design a PCB, get it printed, and then this thing will get a little lighter, but it will definitely get less bulkier, and that's all I got to say about that. So, dog GPS, or cat, but I found that cats usually manage to get them off. Oh, I got a little battery icon here. Okay, so before the camera turns off, let me know what you think of my interesting design. Don't steal, please. Nah, just kidding. I guess the hardest part was is the programming for the microcontroller, but it's really related to another project I got. So I'd say about a good 80% of the programming is done. 80% is done, 20% left, but the most difficult part is probably just 10%. Yeah, thanks for watching. See you later.